Okay, so how do you throw projectiles at an enemy? I have here a very simple scene with a player, and these circles will represent the enemy. So let me just play the scene, and for now we only target the blue circle. So you see on spacebar I draw projectile as that. So let's look at the code first, and this applies also to 3D. It's exactly the same. So I'll try my best to explain this in detail. So first of all, we need a target to throw the projectiles to. So we have here a transform of the target. We have the fireball projectile as a game object, and then we have a float for the moving speed of that projectile. In the update here, we on spacebar we spawn that fireball and throw it at the enemy. So I have this function here, spawn fireball. So this first line here, we spawned the projectile, and at the same time we get the rigid body of that projectile because we want to move it with physics. So with a rigid body, not by transform translate. And if we do that, we have to set the rigid body to kinematic. So I have here the projectile, and the rigid body is set to kinematic, meaning it will not interact physically with anything. It can only be moved by script. So in other words, if it touches something, it will not interact with it. And also it's a trigger, so no physics on the collider. So here we spawn it at the position of the player. Quaternion identity means no rotation, so 0, 0, 0 on the rotation. And at the same time we get the rigid body. Then we need to find the direction towards the player. Okay. So I made a vector tree here that will represent the direction. So to get the direction, we subtract our position from the target position. So let me show you visually what this looks like. Okay. Draw here an axis like that. And let's say we have point A and point B like that. So this is B and this is A. And then if we subtract B from A, we'll get a vector T that looks something like this. Just 1 second, because my brush was too was the incorrect size. Okay, so we get a vector tree like this, but this doesn't represent the direction. This represents both the direction and the distance from one point to another. And we only want the direction. Okay, so like the direction is a vector of size 1. Okay, so the length of it is 1. So we want something like that. And to do that, we use this here. We say that normalized. So this will transform this vector tree, which represents both the direction and the distance between the points. We'll transform it into a vector with the same direction but length 1. Okay, so now that we have the direction, into the we want to rotate the projectile to look towards the player. Okay, and in this case we say that the transform right of the projectile is the direction. Okay, and we do that because if you look at the projectile here, it's orientated towards the right side. Okay, but you might have a projectile that is not like this. It's oriented towards another direction. So you might have it like this, the original sprite, not the game object, but the sprite. If the sprite is like this, then instead of transform right, you say transform up. And this applies for all directions. Even if you have a 45 degree like that, you can work with that as well. Um, so this will rotate the fireball towards the player, sorry, the enemy, and then we just add the force to the rigid body to move it. So linear velocity. So we have the direction times the speed. And that's how you throw projectiles. And for 3D, it's exactly the same, but you don't have to. Actually, you can rotate it, but you don't use this method here. For 3D, you would say uh, fireball look. So the transform look at like that. In 3D, you do it like this. Okay, so that's everything you need to know about projectiles.